Unit 10, Day 4 Notes. Today we're going to talk about tangents. A tangent is a line that intersects a circle at exactly one point. So on my circle illustrated at the right, it shows that line AB is tangent to circle C because it intersects circle C at point A and only point A. So intersects circle C at point A. A point of tangency, the point where the tangent and the circle intersect. So the point of tangency on my circle on the right is point A. A common tangent is a line that is tangent to two circles. So on my figure on the right, line L is a common tangent to both circle F and G. A tangent segment is a segment of a tangent with one endpoint on the circle. So if I were to draw another circle, and a tangent segment, this segment has an endpoint right here and an endpoint here. So let's say again it's AB. Because it starts at circle A, or I'm sorry, let's say circle C. Since the tangent line starts on top on the circle and finishes off in space, then it's a segment. If you notice, in the very first picture, it was a line because it continues in both directions. But since this line segment is pausing and it's only showing between A and B, that's what classifies it as a segment. So let me change the top one to line AB is a tangent, and now its segment AB is a tangent segment. So basically it's just a symbol technicality. Again, lines should have arrows in both directions, and segments have two endpoints. That's the only difference. A circumscribed polygon is a polygon that is circumscribed about a circle if each side of the polygon is tangent to the circle. So on day one, we talked about circumscribed. We looked at it from a circle perspective, with the circle being the outermost figure. But truthfully, any figure could encompass or surround another. So the first figure you see is a triangle surrounding a circle. The second one is a quadrilateral, and the third looks to be a hexagon. So not only are circles capable of circumscribing, but other figures are as well. And again, each side is tangent. So that means it touches the circle in one spot and only one spot. Theorem 1010. In a plane, a line segment is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So what this is saying is if line L is tangent to circle S, then ST, which is your radius of the circle, is perpendicular to line L. And because it uses if and only if, it can be read backwards as well and still be true. So if the radius which is ST, is perpendicular to the line L, then line L is tangent to the circle. Alright, on theorem 1011. If two segments from the same exterior point are tangent to a circle, then the segments are congruent. So if you look at our figure, segment AB and segment CB are both tangent to the circle, and they both meet at point B outside the circle. Outside the circle. So since that is the case, then this theorem is true that AB is going to be congruent with CB. So since AB, segment AB, and segment CB share point B outside the circle, outside circle D, and are tangent to circle D, then AB is congruent to CB. So since since the two lines again are tangent and meet at the same point outside the circle, they're congruent, essentially is what it's saying. So let's work out some practice problems. Number one wants us, or it tells us that JL is the radius of circle J. Determine whether KL is tangent to circle J and justify our answer. So if you go back to theorem 1010, theorem 1010 said a line is tangent if and only if the radius is perpendicular. So we have to prove that JL and KL are perpendicular to each other. So in other words, this triangle KJL, we have to prove that it's a right triangle and that the right angle is right here where where KL meets JL. So first, in proving it's a right triangle, we have to prove Pythagorean's theorem. Again, Pythagorean's theorem, prove that a squared plus b squared equals c squared. So c is supposed to be the largest number, right? And c is supposed to be across from the right angle. Well, The right angle is supposed to be where the radius and the tangent meet. So across from the right angle is 9. So it's not the largest distance. So that's one hint that something might not be right. And that leaves 15 squared plus 8 squared for A and B. Now again, already I'm seeing something's not right. Oh, rewind. Rewind. This distance is also going to be 8. And 8 plus 9 means the total distance is 17. Sorry. So let's fix that real quick. Now that makes a little more sense. That could possibly be a right triangle. All right, so 15 squared is 225, 8 squared is 64, and 17 squared is 269. 225 plus 64 is it 269 or 289? Hold on, let's double check the calculator. My little brain is not perfect. So 17 squared, I think it's 289 now that I'm thinking about it. Yeah, 289. So let's fix that. Alright, and 225 plus 64 does equal 289. So yes, it is a right triangle. Thus, this is a right angle in that corner. So we can say that yes, KL is tangent to circle J. Alright. On number 2, they tell us that JH is tangent to circle G at point J, and it wants us to find the value of x. If you look at it, x happens to be the distance for the length of the radius. So what I can do is it appears that these two segments are going to be congruent. JH and GH. The reason they're congruent is because they both intersect the circle at one point. JH at J and GH at K. And they both meet outside at point H. So again, I'm saying that GH is going to be congruent to JH. And if that's the case, then I can say x plus 8 is going to equal 12. And thus, if that's the case, x is equal to 4. But if this is 12, a right angle, hold on one second. I just had a total brain fart. Again, forgive me. Started off on the wrong track. So we're going to operate example 2 a lot like what we did for example 1. we've got to prove that there's a right angle, or this is a right triangle. So we got to prove Pythagorean's theorem. But if you notice, this is A, this is B, and this is going to be C, this entire side here. So that adds an extra level of difficulty. So brace yourselves, but it can be done. So again, it's a squared plus b squared equals c squared. If a is x, so that means it's x squared plus 12 squared is equal to x plus 8 squared. I don't know if you recall from algebra, but on how to square something of this nature, x plus 8 and x plus 8. Well, to recap in the easy way, if you don't remember the FOIL method, but you can draw a box if you don't remember the FOIL method. And x times x is x squared. X times positive 8 is positive 8x. And the same thing would be here. And positive 8 times positive 8 is a positive 64. So that would be x squared plus combined like terms here. So 16x plus 64. Alright, so then you want to get all your like terms to one side. And in the process of doing so, if you were to subtract x squared, they would cancel each other out on both sides, which would leave you with 144 equals 16x plus 64. So now you have to subtract 64 on both sides. And when you subtract 64 from 144, you get 80. So 80 is equal to 16x. Divide both sides by 16. It might be 5. Pretty sure it's 5, but let's be sure. Yep, it is 5. So 5 is equal to x. And that's all we had to do for example 2. So it was still using 10, 10. On example 3, it tells us that segment AB and segment CD are both tangent to circle D. Find the value of x. So since they're both tangent to circle D and they meet at point B, this is an example of 10, 11. Meaning that those two lines, AB and CB, are going to be congruent. And since they're congruent, we can say x plus 15 equals 2x minus 5. To find x, subtract x on both sides, leaves you with 15 equals x minus 5. Add 5 to both sides, which would give you 20 is equal to x. And number 4 says quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, find x. Alrighty. So, what we know. We know that TS is tangent to circle J. And we know SR is also tangent to circle J. Or SA is tangent to circle J, and SD is tangent to circle J. So these two are going to be congruent because they meet at the same point. So this is also going to be 3. The same idea could be used for DR and CR. They're congruent. So CR is 3. UC and UB are congruent. So BU is going to be X. And the same thing with TA and TB. TB, they're congruent, and it'll be X. So the perimeter, this entire side is X plus 3. Same thing here, X plus 3. This entire side is 6, and this entire side is 2x. So we need to take 2x plus x plus 3 plus x plus 3 plus 6 equals 18. Combine all of our x's. 2x, 3x, 4x, and then 3 plus 3, 6 plus 6 is 12, and it equals 18. Subtract 12 on both sides, which will leave you with 4x is equal to 6. Divide by 4, x is equal to 3 halves, which is the same thing as 1.5. And this concludes your notes for today. Sorry for the interruptions, but we got